When we are shading systems of linear inequalities, we individually graph each linear inequality, and then the solution is the overlapping region. So we just approach each inequality by itself, and then we darken the overlapping region. In this case, we have slope-intercept form inequalities, so y-intercept, up 1 over 3, up 1 over 3, left 3, down 1, left 3, down 1. Dashed line, since there's no equality in that symbol, and greater than is going to be above the line. The second inequality, y-intercept of 4, slope of -1, so rise of -1, run of 1, rise of -1, run of 1. The thing to remember here is that the intersection of the two boundary lines actually means nothing. In this case, this intersection point is not even in the solution set, since points on the first inequality are not members of the solution set. So the intersection point actually means nothing. It's just a boundary point. Okay, less than or equal to, since there's an equal sign, it'll be a solid line. And then that one is individually graphed as below the line. So we can use the same color, or we can use another color and just darken it. I'm going to just stay with blue and just super darken this region to indicate this area right here is the solution to this system. Maybe I'll use both colors. Okay, this does not look great. But these are all of the points where y is both less than 1/3 x minus 2 as well as greater than or equal to, oh, wrong way. Greater than 1/3 x minus 2, as well as less than or equal to -x plus 4. Most of these are in slope-intercept form, which is the nicest. There's not any work that really needs to be done. But if we have a standard form inequality, we should find the intercepts. So 5x equals 20. X-intercept is 4. Remember that we are pretending it's an equality to start with, an equation. Y-intercept is -4. Here we have a dashed line. And we need to plug in the point 0, 0, or some other point to see which side to shade. 0 is less than 20. That tells me that I will be shading this side. Also, negative coefficient in front of y, which tells me that I would need to flip this to a greater than. Y is greater than or equal to -2. Let's use another color for that. That's going to be here, the horizontal line. Y equals -2, and then greater than or equal to -2 is going to be above that line. So those are all the points where the y coordinate, the y value, is greater than or equal to -2. Now let's use a different color. This is my solution set, my region that is overlapping. So above this line as well. Hopefully it is more clear when we're using colored pencils rather than this. This is not very clear. So this area right here is a solution to 5x minus 5y is less than 20. But it's not a solution to y is greater than or equal to -2, so this is not part of the solution set. And then this area here is true for y is greater than or equal to -2, but not for 5x minus 5y is less than 20. So not overlapping, right here, and above. That's the overlapping region.